Hey guys, today we are talking about solving some specific types of log equations that have all of my terms are logarithms. So this is where all of our terms are logarithms. So to be able to solve these, we use a very simple property, and I just love this property and its simplicity. Because all you have to do is just have one log on one side, one log on the other side, and then it's super straightforward. We just cancel out our logarithms. Like if I have one log on this side, one log on the other side, cancel them out, and then we just get our numbers are equal to each other. The reason this works is because, think about it, if you have log of one number equals log of a variable, well, these two things, they have to be the same number because we're taking the same type of logarithm of both of them. So it has to be the same number, so we can just take the logs away and set the numbers equal to each other. So for instance here, on number 1, we have log base 7 of 3x plus 5 and log base 7 of 8x minus 12. And we can just be like, oh, I have one log on this side, one log on this side, so we can just bam, bam, cancel those logarithms out, and we just have 3x plus 5 equals 8x minus 12. So once we're at this point, it's pretty easy. We can just solve for my x. I can just minus 3x to both sides here, add 12 to both sides here. These cancel, and we just get 17 equals 5x. And all I need to do is divide both sides by 5, and we get x equals 17 over 5. Don't let those fractions scare you. Sometimes you just get fractions as your answer, okay? So, long story short, if you have one log on one side, one on the other, we can cancel those out, okay? We can ignore them. So, for number 2, though, I can't just go start canceling logs willy-nilly. Whenever I have more than one logarithm on one side, so check this out. For this problem, number 2, I have one natural log on the left side, and I have two natural logs on the right side. So I can't just start canceling these out at will. So what I need to do instead is I need to combine. So we're going to go back over, we're going to talk about how I can squish these two together to condense these two. So let's first remember, whenever we condense, my first step is that I'm going to need to move my exponents first. Okay, so we're going to move our exponents first. What I mean by that is this 2 in front. Remember, before I can condense, I need to move that 2 to be my exponent here. So I can rewrite this as natural log of x squared plus natural log of 5 equals the natural log of x. Then, remember, if we are adding, that's going to change to multiply whenever I condense. And if I am subtracting, that's going to change to divide whenever I condense. So if I condense these two to be together, we create one natural log of, we have a 5 and an x squared. I am adding, so we're going to combine these together to be 5x squared. If you don't remember how to condense, go back and look at 12:5, okay? And that's how we condense. All right, so then we can just knock off my natural logs here because I have one log on the left side, one log on the right side. I can just bam, bam, take those away, and then I just have x equals 5x squared. Okay? All right, now let's rewrite this over here so I have plenty of room. Okay, so this one is not quite as simple to solve. What I need to do to solve this is I'm going to move my x over to the right side. So I'm going to start off, we're going to move this x over to this side so we can write everything on one side. It is a quadratic equation, and we're going to solve it by factoring. So we're going to have 0 equals 5x squared minus x. And then to be able to factor this out, I'm going to pull an x out as my GCF. Because I cannot factor this with difference in squares, I cannot factor it by doing the x plus. the only thing that I can do is we have a GCF here of x. And so I can pull out an x from each one of these and go 0 equals x times 5x minus 1. Then I have two factors here. We can set both of those equal to 0. I can go x equals 0, and I can go 5x minus 1 equals 0. If I add 1 and divide by 5, we're going to get x equals 1/5. That's one of my answers, and I don't even have to solve this other one. It's just going to be x equals 0. So I have my two answers. Now, remember, we cannot have a logarithm that is negative or 0. So this answer right here of x equals 0 is actually not a true answer, because if I plugged in 0 here, it would create a logarithm of 0, which doesn't work. So x equals 1/5 is going to be my only true answer. Okay, let's move on here. Let's take a look at number 3. So number 3, similar thing. Okay, number 3, this time I have two logarithms on the left side, one logarithm on the right side. So to be able to solve this one, remember, first step whenever we squish our logarithms together is that we need to move my exponents. So my first step here is I'm going to take this exponent, I'm going to move it to be on top of my x squared. So I'm going to have log base 8 of 45 minus log base 8 of x squared equals log base 8 of 5. Then I can squish these two together. Now remember, whenever I am subtracting, like I am here, whenever I squish these together, we are going to divide. So whenever I write this back out, it's going to be, log of, it's going to be log base 8 of 45 over x squared equals log base 8 of 5. So then you can see that I have one log on each side. So all I need to do is cancel out this one, cancel out this one. We're going to have 45 over x squared equals 5. Once again, I'm going to take this over here to finish working it out. So if I have 45 over x squared equals 5, first off, I need to clear out this fraction. So to do that, I'm going to multiply both sides by x squared. Okay, these are going to cancel. And I'm going to get 45 equals 5x squared. Then I'm going to divide both sides by 5. And that's going to give me x squared equals 45 divided by 5 is 9. Then, last step to solve, we're going to square root both sides. And the square root of 9 is plus or minus 3. But we only care about the positive one because that's going to be my answer. Okay, so my answer is x equals 3. All right, let's move on here. Let's take a look at number 4. So number 4, we have natural log of x plus the natural log of x minus the natural log of 3 equals the natural log of 12. So I have 3 natural logs over here. Now, none of these have an exponent to move. They don't have a number in front. So none of these have a number in front that I need to move, so we can go straight to squishing these 3 together. Okay? So, since I have 3 values, I have 1, 2, 3 values here. We're going to need 3 values whenever I squish all 3 of these together. So we can rewrite it as the natural log of, well, my first one is an x. And then I'm adding, so I'm going to multiply another x on here. And then I'm subtracting, so I'm going to divide 3 equals the natural log of 12. Okay, then I have 1 natural log on the left side, 1 natural log on the right side. So all I need to do is cancel these out, rewrite this, x times x is x squared. We're going to go x squared divided by 3 equals 12. And then to solve this, we're going to multiply both sides by 3 to clear out my fraction. That's going to give me x squared equals 36. Then I can just take the square root of both sides, and that's going to give me x equals plus or minus 6. But once again, I only care about I only care about the positive. All right? So there you go. We just squish them together, and once I have one log on each side, we can just cancel those logs out. So hopefully you're seeing that it's pretty easy to solve these. Okay, let's turn the page, and let's take a look at number 5. So number 5, it seems really complicated. This is our longest, most complicated problem here today. We have 2 logs on the left side, 2 logs on the right side. And to be able to combine these together is kind of a difficult task. But what we're going to do here is to combine these first 2 logs together. I am subtracting. So I can, first, I don't have any exponents that I need to move. So this is going to be log base 2 of this one minus this one. So we're going to divide. So remember, we subtract here, we're going to divide. So it's going to be 2x minus 1 over x plus 5 equals, over on this other side, I do have some exponents that I need to move. So I need to move this one to be here, and I need to move this one to be here. So this turns into log base 2 of 36 to the 1/2, and this turns into log base 2 of 2 squared. Now, 36 to the 1/2, you can grab your calculator, you can plug that in, and you go 36 to the 1/2. But I'm just going to tell you, 36 to the 1/2 is 6. So this is actually going to be log base 2 of 6 minus log base 2 squared is 4. Then I can combine these together, okay? So we can combine these together. Now that I don't have my logarithms, we can just rewrite this as log base 2 of 6 over 4, okay? So that's going to be what I write over here. We're going to get log base 2 of 6 over 4. All right, so we simplified this side down. We simplified this side down. We got my 2 things. And now I can just cancel out my logarithms. I can just cancel this one and this one right out. And that leaves me with 2x minus 1 over x plus 5 equals, now this 6 over 4, I'm going to go ahead and reduce it. So stay with me. I'm going to reduce this 6 over 4 to 3 over 2. Just stays that fraction. We're just going to reduce it to 3 over 2. Now I have one fraction equals another. To be able to solve this, I'm going to cross multiply and divide. So I'm going to cross multiply. I'm going to go 3 times x plus 5 and 2 times x minus 1. This is the same thing as finding a common denominator. So 2 times 2x minus 1. See what that is. 2 times 2x minus 1 equals 3 times x plus 5. Then we're going to distribute 2 times both of these. 2 times 2x is 4x. 2 times negative 1 is negative 2. 3 times both of these. 3 times x is 3x, and 3 times 5 is 15. Then we're just going to rearrange. Let's move this 3x to this side. Let's add this 2 over here to this side. These cancel. 4x minus 3x is 1x. 15 plus 2 is 17. So long story short, I hope you see that this really wasn't that difficult at all. All right, let's move on now to number 6. So number 6, I have log base 10 of 2x squared plus 3 equals log base 10 of 7x. So this one, thank goodness, I don't have to condense at all. I only have one log on each side. So the only thing that we're going to do is cancel these logs out. And we're going to have 2x squared plus 3 equals 7x. Now, this one we're going to need to solve by factoring. It is a square, and we're going to factor using the x plus method for trinomials. So to do that, we're going to minus 7x to both sides. We're going to move everything to one side. We're going to get 2x squared minus 7x plus 3 equals 0. Then let me write my x plus over here. So on top of my x, we're going to use my a times c. So remember we have a, b, and c. So on top of my x goes a times c. So 2 times 3 is 6. On bottom of my x is my b, which is negative 7. Then we think of 2 numbers that multiply to 6 but adds negative 7. And those 2 numbers are going to be negative 6 and negative 1. So those are my 2 numbers that are going to go over here. Then we write ax, and my a is 2, so we're going to go 2x, 2x. Now, we simplify if we can. This 2x minus 6 can simplify to become 1x minus 3. And this 2x minus 1 cannot simplify, so it's going to stay just 2x minus 1 equals 0. Then I have my two factors. We're going to set both of my factors equal to 0 so I can solve. If I add 3 to both sides here, we get one answer of x equals 3. And if I add 1 and divide by 2 here, we get my other answer of x equals 1/2. Okay? So there you go. X equals 3 and x equals 1/2. All right. And our last one here, number 7. So number 7, I have log base 3 of x plus 5 equals 4. Now, this one is different from any other problem you've seen so far today. And the reason it's different is because it only has one logarithm, and my other side does not have a logarithm. So whenever we only have one logarithm, we can't just go canceling it out. We have to be able to have one logarithm on each side to be able to cancel. So what we do is we solve this like we did yesterday. We isolate my logarithm, and we're going to rewrite. Okay? We're going to rewrite. If there's only one logarithm, we're going to go from log base b of my value equals p to b to the power of p equals my value. So let's rewrite this. 3 to the power of 4 equals x plus 5. Now, 3 to the power of 4 equals 81. So we're going to have 81 equals x plus 5. And then all I need to do is minus 5 to both sides. And we're going to get x equals 76. And that's going to be my answer on that one. All right, guys. I hope this video has been of some help to you. If you have any questions, as always, be sure to let me know.